Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will help demonstrate how to check your Zoom 2 optical power meter for proper operation using a WaveSource multimode light source.
Patch cables and test equipment should always be checked prior to testing to ensure accurate and reliable test results. Usually a good time to do this is at the beginning of every testing day. In this procedure, we will be using a Zoom 2 optical power meter and the multimode port on a WaveSource light source. Now you'll notice that there are two patch cables and one mating sleeve used for this procedure. Okay. Because this is multimode fiber, we're wrapping one of these reference cables around a mandrel per testing standards. Okay, this cable is used to zero out the equipment and also to connect the wave source in to the link under test. The second cable is used to connect the zoom into the link under test. And this mating sleeve is used to connect both of these patch cables together for the purpose of making sure they're working properly. Okay, one of the main concerns when choosing reference cables and test cables is that they have the correct connector types on them. We need to make sure one end of the patch cables connect into the testers, and the other end of the patch cable connects into the link under test. Now, these don't have to match. You could have an SC to LC cable. However, in this case, we're just going to assume that we're using SC connectors all the way around, including in the patch panels. Okay, the first step is to power on both testers. So we press the power button on the zoom and the power button on the wave source. You will notice that the multimode port is lit by default. You may not be able to see it very well, but the indicator LED here is red, which indicates that 850 nanometer is being output at this moment. Okay, on the zoom, we look at the display and we see that we're set to 850 nanometers, set to dBm, and that our reading is low. What this means is that there's no measurable amount of light coming into the photodetector. This is because there's a dust cap on the detector. If we remove this dust cap, we'll notice that we get a power reading. However, this is a very low power reading simply because we are measuring ambient room light. So just keep that in mind when you see a reading like this. It could be ambient room light, especially if there's nothing connected into the detector port. Okay, the next step is to check the mandrel wrap reference cable. So we remove the dust cap from the wave source. We plug in one end of the reference cable into the multimode port and the other end into the detector port on the zoom. Okay, notice we have a reading of minus 20.15 dBm. Okay, this is actually a good reading. Our target value is minus 20 dBm. Now the reading could be a little higher, a little lower, but it's going to be close. In this case, it's a little bit lower, but it's still acceptable. Okay, if we're reading a little bit lower than minus 21, then we may want to consider replacing the patch cable for referencing. But in this case, we have a good patch cable here. The second thing we want to do now is, if we're doing a dual wavelength measurement, is to make sure that 1300 is also at a proper power level. So we press the wavelength button until we see 1300 on the zoom, and then we press the wavelength button on the wave source to switch to 1300. Okay, notice we have a reading of minus 19.96 here. Okay, again, very close to minus 20. In this case, it's a little bit higher, but we're not below minus 20. So we know that this patch cable is good, and we know that the units are within their NIST calibration. Okay, for the purpose of checking this cable here, it's better to zero out our reference cable first. So what we can do here is we press and hold the 0 button. Notice it switches to 0, and for 1300 we're reading 0 dB. Okay, this is why we call it zeroing, because we've just told the meter that minus 19.96 is our starting point for measuring loss at 1300. Okay, but we also want to switch or set reference for 850, so we're going to press the wavelength button on the wave source. Again, it will switch back to red, or 850, and then we need to switch the wavelength to 850 on the zoom. So we simply press the button until it reads 850 nanometers. And also, we want to make sure that we're reading in dBm mode. So we press the units button until we read dBm. Okay, notice it says minus 20.15. Okay, that's also within our specifications. It's not below minus 21. So 850 nanometers is also okay. So we can zero out this wavelength as well. All right, so now we have both wavelengths zeroed out. And this is just temporary. It's just a temporary reference. But it's zeroed out. Now we can check this cable here. In order to do that, we need to disconnect from the detector. And notice that we get a low power reading, which we're not plugged in, so we are measuring ambient room light. We connect the mating sleeve on the end of the reference cable. We plug the power meter test cable into the other side of the mating sleeve. And finally, we plug the other end of the test cable into the detector port again. All right, notice we're reading around minus 0.42 dB. Okay, this means that this patch cable and this adapter are introducing about, or a little less than a half a dB of loss. This is okay. You don't want to exceed 0.5 here. Okay, but it's also helpful to check, again, to check 1300 nanometers. So we'll just switch to 1300 on both units. Okay, notice we have a reading of 0.12 dB. Okay, so at 1300, this patch cable and this adapter are introducing 0.12 of a dB, which is good. We're not exceeding our half a dB limit. So this patch cable, or both of these patch cables together, are okay to use for testing.
If the power level falls below the acceptable power level range, debris such as dust, dirt, or finger oil may have collected on the connector end face or in the equipment's optical ports. Thoroughly clean and inspect all connector end faces and equipment's optical ports according to industry standard cleaning procedures. Several cleaning cycles may be required. Keeping connectors and optical ports clean at all times helps to keep test equipment in good working order and proper calibration, ensuring accurate and reliable test results. When not in use, dust caps should be kept on fiber connectors and optical ports to keep debris from collecting on the surfaces of the connectors and ports. During testing, it is highly recommended to clean and inspect both connectors and optical ports every time a connection is made. Failure to properly maintain your test equipment could needlessly result in costly repairs. For example, over time, repeated connector insertions into a dirty optical port could grind the debris into the optics in an equipment port. This type of damage is permanent and cannot be repaired in the field. If the problem still exists after thorough cleaning and inspection, the patch cable may need to be replaced. Patch cables are typically rated for a few hundred connector insertions, but can prematurely wear out or become damaged if they are not properly handled and maintained. If the power level is still too low, even after patch cable replacement, contact OWL Technical Support for assistance. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.